Hello everybody, let us start lecture 51. The course is on phase diagrams in single component and binary systems. And today's topic will be the same what we have discussed in the last class, that is enthalpy of mixing as well as Gibbs free energy of mixing. And when we deviate from ideality, what will be the effect on the delta G mix, and subsequently we try to see the stability of a phase. Now, let us just check what we have done in the last class. In the last class, we have started with a regular solution model. For the formation of binary solution. It is basically A and B system, and we are doing it at a particular temperature and pressure. So, T and P is 1 atmosphere are taken constant, fine, and we have taken 1 mole of solution. So, X A and X P are the mole fraction of A and B, that leads to 1 mole. So, all the quantities Gibbs free energy terms as well as enthalpy terms are based on 1 mole. Now, we have checked some of the formulas when we talk about ideal system, we have seen that delta G mix ideal equal to delta H mix, I can put ideal minus T del S mix ideal, and there it is 0. So, it is nothing but R T X A ln X A plus X B ln X B. Since and for non-ideal system, so we see that delta G mix equal to delta H mix minus T del S mix, and where del S mix in case of non-ideal is equal to del S mix ideal. So, only configuration term is there. Entropy is considered. So, then it can be written as delta H mix is omega X A X B plus R T X A ln X A plus X B ln X B. And if I try to see the solution Gibbs free energy G 2, which is for the solution, G 1 which is unmixed condition, plus delta G mix. You can replace this delta G mix with this, and G 1 can be written as X A G A naught plus X B G B naught. Fine. Here also G 2 can be written as G 1 plus delta G mix. So, the delta G mix expression can be put here, and G 1 is also same as what we have considered in case of ideal, X A G A naught plus X B G B naught. Fine. So, that is what we get the solution Gibbs free energy with reference to with respect to the pure condition. There we are just adding delta G mix, and we have started plotting delta G mix by R T as well as delta H mix by R T, and delta H mix can also be expressed as R T alpha X A X B, where alpha is nothing but omega R T. Alpha is a parameter which helps us to consider the calculation of delta Hmix by RT, and that alpha can be taken as a small number. So, these two numbers, this becomes alpha XA XB plus XA ln XA plus XB ln XB. Okay. In case of ideal, this term will not be there. So, this is nothing but alpha XA XB. And there we have seen that as we keep on increasing alpha term, there would be a situation that there will be beginning of delta Gmix by RT plot beginning of having a slope change around the mid compositions. Okay. That is what we have seen, and that happens because this term, as it becomes higher and higher with the increase in alpha parameter, we will see that around mid concentration this particular value would actually become more than the value of this quantity. So, this quantity is nothing but del S mix divided by RT with a minus term. Fine. So, that term, this term, if we try to see the mod term, the value, that value would be less than the value of this del H mix by RT term around mid concentration at some point of time, that because this del H mix by RT value starts superseding del S mix minus del S mix by RT value, with the value part I am talking about, because this quantity is always negative. Here we have to also add one term T. Okay. So, then initially at a lower value of alpha, we will see the delta Gmix by RT plot is always convex downward, but around 2, as we have seen before, around when alpha becomes around 2, we see that the curve, the delta Gmix by RT with composition plot starts having a slope change, and it is no longer remaining convex downward, rather with the increase in alpha around mid concentration, it becomes convex upward. Okay. So, that is what we have seen, and we have also seen as we keep increasing alpha, let us say alpha is very high, but still we could see that around the extreme ends of that concentration axis, either pure A or pure B side, we see that there will be still a little bit of convex downward, and then of course, after that there will be convex upward shape of delta G mix by RT, okay, with composition. So, then we said that we have to answer to these two particular things. One is definitely why there is a dip as we increase alpha at the end of the composition axis, and second part is what phase would be stable. Okay. So, these two factors we have to respond. Fine. We see that if we try to look at delta G mix by RT plot, which is this is x A equal to 1, x B equal to 1, this is x B, composition is changing this way. We see that initially the curve, this is delta G mix by RT at a lower value of alpha, and as we increase the alpha, this line starts moving upward, but still it is convex downward. So, this same delta G mix by RT plot, alpha increasing, and when alpha is around 2, we see that So there is a kind of so had it been normal convex downward, a dotted line would have been the shape, but instead of that, alpha with increasing alpha, it takes a shape like this, further increase in alpha, further increase. Now, once we reach to this level, after that once we increase the alpha, you see the slopes are changing, okay, around mid concentration. Fine. Initially the slope was the curve, actually I would say curve was convex downward. Now it is actually it can be broken into two curves, two convex downward and one curve with a convex upward. Okay. So that situation arises. Now, so I can put it in a different color. So this is one, this is another one, and this is another one. So like that way the slopes are changing. Now as we keep increasing the alpha, we see that it becomes like this. So this point shifts to the left and this point shifts to the right, this and this, and then if we increase further, we will see that there will be still a dip. So this dip is there, okay, but here it is alpha is very high. Why? There is a small convex downward shape in delta Gmix by RT or delta Gmix versus XP plot at extreme ends in the composition axis. Okay. So this is nothing but delta Gmix by RT plot and this is composition, okay, XP. So this question we have to respond, and second question is the stability of solution, or rather what solution and composition will be stable. Okay, we need to respond to this question. Now, first question, in order to respond the first question, so let us actually do that. So, the first question is why there is a dip even if at a very high value of delta Hmix or delta Hmix by RT or higher alpha values. Okay. So, while responding to the first question, let us get to the equation of G2 or delta Gmix, let us say, which can be written as delta Hmix minus T del S mix, can be written as omega XA XB plus RT XA ln XA plus XB ln XB. Now, if we make a kind of try to see the slope of this particular delta G mix with XB, let us say. So, let me plot delta G mix in one case. Let us say this is in case of ideal, which is, and this is, let us say, delta Hmix. So, this is XA XP at a particular value of omega I am talking about. This is temperature constant, pressure is equal to 1 atmosphere, which is nothing but minus T del S mix. Then my delta Gmix plot in case of non-ideal would be, okay. So, this is delta Gmix for non-ideal, which is coming with the addition of this and this, not this one and this one. If we add them, then we can get delta Gmix for the non-ideal solution. So, that can be written as, so that means we are taking slopes over this plot. So, this is constant. So, we can write 1 minus 2 xp plus RT ln xb minus ln xa. So, then I can write this as omega 1 minus 2 xp plus RT ln xb minus ln 1 minus xp. If you do that, you will get this. If you do this xp for this particular term, you should get this. Now, let us say I want to see the slope, this is nothing but the slope of delta Gmix at different concentration or xp. Okay. So, if xp tends to 0, that means very dilute solution. If that happens, then I can write this slope dxp equal to tau xp equal to, so this becomes omega plus RT, it becomes minus infinity and this becomes 0. So, overall it becomes minus infinity. So, what does it mean? So, that means, and if xp varies this way, so this is xp equal to 1 and xp equal to 0 here. So, at this point, which is very close to 0 value of xp, I see that the slope over this line is nearly infinite. So, the slope is gradually it is having much steeper value, but when it is coming nearly 0, the slope becomes infinite. What does it mean? It means that when I try to make any ultra pure metal, let us say, when I try to make an ultra pure metal, that means I am trying to make a pure A. So, I am taking away B gradually. So, if we start with pure A, ultra pure A, let us say, now if I have a little bit addition of B, the slope would become minus infinite. That means, the change in value of delta Gmix is extremely negative. So, negative infinity. So, that means, there is an extreme spontaneity for ultra pure A to take B in the form of solution. Okay. Similar thing happens if I go to the other end, when I try to make ultra pure B. So, ultra pure B, if I start with at a particular temperature, that ultra pure B would have infinite free energy change towards negative side if A is added a small amount. So, that means both the sides, when we starts going towards the pure state of A and B, I see that the system has infinite possibility to capture impurity from the surrounding, okay, because the free energy change becomes negative infinity. So, this suggests that free energy change when an ultra pure metal, in this case A, is kept at a particular temperature and pressure, would be minus infinity if a tiny amount B is added. So, that means the solution formation becomes spontaneous. In fact, not only spontaneous, it's extreme spontaneity, because the free energy change is negative infinity. Fine. Now, one must be wondering that here delta Hmix is very high, okay. But if I try to look at when Xb tends to 0, what will be delta Hmix dxb? That slope is nothing but equal to omega, and omega is a definitely positive quantity, but it has a finite value. So, this has a finite value. Okay. So, when it has a finite value, and that means the change in enthalpy of mixing as we reach towards pure state is finite, whether as we reach to pure state the addition of B or the solution formation ability is decided by free energy change, which is minus infinity. So, that means one part which is the positive term, this term is positive and this term becomes negative infinity. So, hence it will be always negative infinity. Fine. So, that slope part. So, I am talking about the slope. Please understand that this is a slope part. Okay. So, the change also becomes negative infinity. Now, if you recall, we have already seen that delta G mix, delta G partial bar m of B tends to infinity minus infinity if x b tends to 0. We have proven before. Okay. So, this also means the same thing. So, the partial molar Gibbs free energy of solute B, when it is mixed in ultra pure A, the change becomes, the mixing free energy change becomes negative infinity. So, there also it gives the same indication that at both ends, whatever be the value of omega, because omega will always have a finite quantity, finite value, there will always be a chance of solution formation. And as we have seen before, the solution, homogeneous solution formation ability is decided by the convex downward shape, and here also we see that there is a convex downward shape. Hence, that those two ends there will be always a convex downward shape, followed by a slope change, and then it would become definitely, as we go away from pure state, we see that the slope will gradually change, and it will become, the curve will become convex upward. Okay. So, this is very important, this particular explanation. 100% pure substance, in this case is metal, is impossible to make. Impossible to make. Now, as we see that if we just consider a kind of practical situation, if you buy pure metal, so if the purity is 95%, the metal would be cheaper. As we go higher and higher purity, the metal becomes costlier. Why? Because we have to take the impurity out of that metal, and it becomes extremely pure. That time the cost can increase exponentially. Why? Because we have to take away that particular impurity or the solute phase from that solvent or the solution, providing extremely high energy. So, it is a cost of energy that increases the cost of the pure metal. Okay? And the reason lies here, because free energy change, when we add a small quantity of solute into ultra pure metal, the free energy change is minus infinity. So, there is extreme spontaneity for the formation of solution. Okay? So, we have just responded to one question, where we see that at two extreme ends, whatever be the positive values of delta H mix, there will be always some one portion of both ends, there will be a small section, it will be convex downward. So, solution formation is homogeneous solution formation becomes a stable phase there. Okay. So, let me stop here, we will continue our discussion, we will try to respond to the next question. Okay. Of course, one question is here also tells me that that convex downward part will be the possibility, but over the entire composition range, what will be the phases that would become stable if we have a situation of high value of delta H mix, and also the shape of the delta G mix curve is initially convex downward and then it changes to convex upward. So, that kind of situation, what will be the phases in between those two convex downward zones. So, let me stop here, we will continue our discussion in the next lecture. Thank you.